Hello, I'm Rüdiger and I'm very happy to introduce to you now IDA, the intraoperative digital aortography. So our vision is to save patients' lives and to improve their quality of life by providing smart, easy to use, reliable and affordable medical devices to heart surgeons. We address conventional heart surgery procedures in which various manual instruments are used. The problem of these instruments is that they are not always working very precisely. On the left, you see here a sizing ball used in aortic valve replacement procedures to determine the diameter of the vessel ring. That is necessary to determine the right size of aortic valve prosthesis. And here you see a ruler or caliper, which is used in aortic valve repair procedures to measure certain heights and lengths of the aortic valve leaflets. That gives an indication on the closing competence of the aortic valve after repair. But there might be leakages undetected and therefore not corrected. So non-precise information could lead to wrong decision. And always the truth comes out post-operatively in the swallow echo. And often that leads to reoperations. That is always bad because by this, the risk of escalations increase. Escalations could be renal failures leading to strokes, and all these escalations have bad consequences for the patient. So our solution is IDA. IDA is simulating real pressure conditions by putting pressure on the aortic valve, closing it by this, and putting an imaging on it. So this will replace manual instruments, allows a reliable sizing of the aortic valve, and the determination of remaining leakages. That lead in case of replacement that the right prosthesis type and size will be chosen. In case of repair, that the right decision will be taken whether to proceed with the operation or to correct first the aortic valve.
Let me briefly introduce our patented innovation. Imaging on aortic valves during and after reconstruction procedures under diastolic pressure guides the surgeon to an optimal clinical outcome. Our system consists out of two parts. One is the pressurizing and imaging system. We have 3D optical sensors and laser patterns to bring the best accurate measurement. An ultrasound sensor which shows existing leakages, and a liquid supplying system. The imaging device is controlled by our control unit. This control unit is doing the whole image processing. The image recognition takes place to give qualified data by physicians to train the AI. This is connected to our database system. We are an API for the cloud service, and the control unit is connected via our API to the hospital IT infrastructure. I will show you a demo version after the pitch.
The surgical value is, in case of repair, a reliable pressure tightness test. If there is determined loss of pressure, the severity of a remaining leak will be determined and the leak will be localized. The closing competence will be determined, and the entire valve will be measured in 3D. Surgical value here is that there will be no intraoperatively undetected leakages anymore. case of aortic valve replacement, the basal ring will be measured under pressure, which will lead to a right choice of the size of prosthesis, and in consequence lead to that there will be no further patient-prosthesis mismatches any longer. The clinical outcome will be great, as mortality, morbidity rates will decrease and the quality of life will increase. So what we foresee is for both procedures that the 30-day mortality and morbidity rates will increase by 50% down to 6.5%, and the 5-year mortality rates also will decrease by 5% down to 3.5%. Plan a fast go-to-market with our first product, EDA1, which is addressing the aortic valve repair procedures. This is possible due to the fact that EDA1 will be classified most probably as Class 2 product, as it has no direct contact to the native tissue. This makes a shorter certification pathway possible. 2 years later, we plan the market entry of EDA2, addressing the aortic valve replacement procedures. That will be definitely a Class 3 medical device, as it will be fixed on native tissue, but it addresses the huge market of replacements. Further products are planned. The entire market is big, with 6 billion euro and still increasing, and in 2030 we plan to sell about 33,000 pressure and imaging devices per year. This leads to the pricing strategy. So the pressure and imaging unit is planned to be a disposable, sold for 800, respectively 2,400 euro in the EU or US. And the control unit will be sold by 35,000 euro or 100,000 euro in EU or US. And additionally, a monthly service fee will be charged of 700 euro or 2,000 euro. Financial plan shows the huge potential of IDA. We plan cash break even in the mid of 2026, and as already said, about 33,000 sold disposables in 2030. Now we raise at least 300,000 euro that enable us to go through the demonstrator development phase for EDA1, and to do the about 10 preclinical acute trials in the pig until the mid of 2022. Then we plan to raise a seed round of 3 million euro and also to successfully to apply for governmental grants of 1.5 to 1.7 million euro. This money will bring us through the certification process of EDA1 and also finance the development phase of EDA2 until ready for certifying state will be reached. In the end of 2023, then we raise an A round of 10 million euro to finance the go-to-market of EDA1 and certification process of EDA2 and also go-to-market of EDA2. So now, as already said, we are applying for at least 300,000 euro or more. That would enable us also to leverage 300k euro of the NRW bank as convertible loan. That must happen until end of this year, as the NRW bank has to transfer the money and spend the money out of the existing fund until end of year. Then this fund will be closed. Of course, we are invest registered, And the seed round money of 3 million will enable us to leverage 1.5 to 1.7 million euro governmental grants on top. The whole money will be used for the certification process of VIDA 1 and the development up to ready for certifying state prototype of VIDA 2. Yeah, exit options there are many. For instance, heart valve processes manufacturer or manufacturers of imaging devices and heart-lung machines.
Meet the Klavant team. On the left, you see the physician in our team, Javier. Javier is heart surgeon and inventor of the already granted patent. In the middle is Rüdiger. Together with Rüdiger, I am managing director, and he is responsible for finance and regulatory affairs. I'm responsible for business development and product. Our development team consists out of 3 persons. Jan as an experienced advisor, and Dennis has more than 4 years experience in the field of stereo vision on native tissue. And Thomas is responsible for prototyping and IT infrastructure, APIs to the hospital infrastructure. During the last year, we won several competitions in the field of life science, and we are underrunning several accelerator programs like the 4C accelerator in Tübingen and the Kickstarter program from German Accelerator. We are part of the Health Innovation Port from Philips Healthcare. We hope we raised your interest to support Klavant. In case you have any questions, feel free to contact us. We are more than happy to answer every question. Thank you very much.
Hello, my name is Michael. I'm responsible for product and business development, and I want to present you the demo version of our user interface for the intraoperative digital aortography. What we see here is a live image. It's a live image from the aortic valves of a 76-year-old female patient. We pressurized it to 65 mmHg, and the image will be recorded and saved to the DICOM archive. From here, you can easily switch to the measurement mode. Now we are in the measurement mode. After several imaging processings, we are generating a so-called depth map with our stereo vision system. From the depth map, we can generate all the important height information to measure the geometric size of the aortic valves. You can easily point the important measurement points like the heights of the cusps, like the geometric height, and easily measure it. Now we are coming to the most important point to assist the surgeon during his operation procedure. He wants to know several specific points, like the heights of the cusps. You want to measure the geometric heights of the leaflets. Right now, we are doing it manually, but in the near future, our artificial intelligence system will do it on its own. This is a perfect assisting system after aortic valve reconstruction to give surgeons a good idea and quality control during the operation of the aortic valve. With this information, the surgeon first time ever gets geometrical structure information under pressurized aortic valves after reconstruction procedures. And this is a benefit because To know the geometric size and competence of the aortic valves has a deep impact for patients' quality of life and freedom of reoperation.